Hi guys, welcome back. In the previous video we got a basic idea of what surds and irrational numbers are, and in this video we'll be going to be looking at a few examples on how to apply what we've learned so far. The questions that we'll be looking at in this tutorial come from the New Century Maths New South Wales textbook for the advanced course. Now the front of the book looks like this, and I'm sure everyone watching from Sydney or somewhere in New South Wales will have a similar copy lying around somewhere at home. So let's get stuck into it. The first questions I'll be looking at will be from the last column of exercise 1.01, and I'll be going through each one providing work solutions. Okay, so question 1, which of the following is a surd? Now they've given us 4 answers here, root 64, root 100, root 250, and root 400. So to answer this question correctly, what we need to do is we need to remember what is a surd. And we know that a number is a surd if we can't represent it in the form of a fraction. So in order to do this, we'll put each one into our calculator and get the following results. So let's start with A. From looking at this one, putting it in our calculator, that this is equivalent to 8, because what that's saying is 8 times 8 equals 64, which is the number under the root. Now we should know that 10 times 10 is also 100, so we can say that that is 10, and we can say that these other two are a little bit more tricky. So let's try and put both of these into our calculators. So putting in root 250, we can see that that gives us a very ugly number. So that ugly number that I can see is 15.8113883. Now that doesn't look like it can be represented in a very clean fraction, but I'm going to put it into I'm going to press my fraction button on the calculator, and it is not doing anything. So this number cannot be represented as a fraction, so we can safely say that this answer is going to be C. Now just to make sure, we'll do D in case, so we'll put root 400 into our calculators as well, and we can see that that is 20. So again, each of these can be written as a number, be written as a fraction. So 20 over 1, 10 over 1, and 8 over 1. Whereas this is very tricky. The only way to represent it properly is with that, the surd, root 250. Okay, so that first question was pretty easy. Let's get on to question 2. So which of the following is not a surd now? So that you can see they've given us 4 options again, very similar question to the first one. The first option is root 84, second option is root 196, third option root 27, and fourth option root 160. So again, we have to remember what a surd is. If we can represent any of these in a fraction form, then we will know that it is not a surd. So we'll put in root 84, and we can see that that is equal to 9.1651513. Now it doesn't look like it's going to be able to represent as a fraction, but again I'm going to press my fraction button and nothing happens, so I know that that can not be represented as a fraction and is therefore a surd. Let's go on to the next one, root 196. Okay, and I've gotten 14. Now, assuming that these two, if you put them into a calculator, will be something similar to this here, we know that this here can be represented as a fraction. 14 over 1 is probably the easiest one to do, and therefore it is not a surd. So the correct answer is B. Question 3 now. This one says, select the surds from the following list of square roots. Now, in the textbook, there are a lot more here, but because I said we're going to be doing the last column, we're just going to look at these 2 here. So we've got root 4.9 and root 288. So these are just square roots. So what that means, we're going to just put those into our calculator and see whether we get a number that can be represented by a fraction. So let's put in root 4.9. So as we can see, that probably doesn't look like it's going to be able to be represented as a fraction. We'll double check that, pressing our button. Nothing happens, so we can safely say that this is a surd. Okay, and we'll give that a tick, correct, a surd. Alright, now let's go on to our second option, so root 288. Again, following the same thing, we'll put in the root 288 into our calculator. Okay, and that, again, that doesn't look like it's going to be able to be represented with a fraction, but we'll try anyway. No. So again, this is also a surd. So that there is also a surd. All right, easy. Let's move on to the next question. Question 4, is each number rational or irrational? So a bit of a different question now. Now again, because we're doing the last row here, we're going to be doing F and L. So looking at F, let's get onto this one first. So the first thing we're going to have to remember is what is a rational number and what is an irrational number. So that rational number is another name for a number that can be represented in a fraction form. So irrational is the opposite, where we cannot represent it in a fraction form. So looking at F, let's get onto this one. Let me just change this, that's it. Okay, now what that dot means on top of the 5 is it means recurring. So basically what it's trying to tell us here is this is the same thing as 1, 3, 5, 5, 5, 5, 5, 5, 5, and it goes on forever. So basically what we're going to do for this one is usually recurring means that it can be represented as a fraction. So just to prove this, what I'm going to get you to do is I'm going to get you to put in 1.355555555 into your calculator, press equals, and then press your fraction button. Okay, if you've done enough 5s, then you should be able to see that it can be represented as a fraction, and that fraction is 61 over 45. So therefore this can be represented in a shape of a fraction and is therefore a rational number. Now I know it doesn't look like it, but if you think about it, there are other numbers using recurring, such as famous one 1.333333333, or you could write it down as 1.3 recurring. Sometimes it's written with the dot, sometimes it's written with the bar on the top. And essentially, this is another way of writing 1 and 1/3. So basically, if you put 1 divided by 3 in your calculator, what that actually is 1/3, but the calculator is represented like this. So now let's go on to this second example. So we'll get rid of all of this. Now, this is a tricky one. So we've got a root of a root. So when this happens, you're probably going to want to draw in little brackets. And remember, using our BIDMAS notation. So BIDMAS, remember, is the order of operations. We do our brackets first, then our indices, then our division and multiplication, and then our addition and subtraction. So we're going to work our way out from the middle here. So root 4, that's asking us which two numbers, or which number, when times by itself, gives 4. And hopefully we should know that 2 times 2 equals 4. So therefore this number here is the same as 2. So we can rewrite this thing now as square root of 2. Now this looks like it's in a familiar form to what we've had before, and we're going to put that into our calculator. Now we should know that root 2, when we put it into our calculator, it's a very long ugly number. I'm not going to write it out, but that is an irrational number. If you don't believe me, press your fraction button, nothing will happen. So we can therefore say that this is an irrational number. Okay, on to the next question. Okay, so question 5. Arrange each set of numbers in descending order. Now again, we're going to the last column, so we're just going to do this one question here. So it's given us the third root of 20, 2.6, and hopefully you can see there's a dot on top, so that means 2.6 recurring, and 2 and 7 over 9. So 3 different forms of number that they want us to put in descending order. So remember, descending order means big to small. So what we're going to want to do first in order to do this is we probably want to get them all in the same form so that we can compare them easily. So this here, 2.666666, is in decimal form. This 2 and 7 over 9 is in fractional form. And this is in surd form. Now, the easiest one to convert to, seeing you've probably got your calculators there, is going to be decimal form. So we can leave 2.666666 as it is, but we are going to want to change these two into decimal. Now, the easiest way to do that is to put that into your calculator. So let's put the third root of 20 in. So remember, we press Shift and then we press our third root button, 20, and we get roughly 2.71. The number goes on, but I'm going to round it to 2 decimal places. If we round this to 2 decimal places, we've got 2.67. Hopefully they're not going to be too similar. And then putting this one into our calculator, you can do it. You're going to press your Shift button, and then you're going to put press your fraction button, type in 7, down a key, and then 9. So if you then pressed equals, you should get it in decimal form. Okay, in my case, I got 25 over 9, which is 2.77777. So 2.7 recurring, so we can round that to 2.78. Now that they're all in the same form, it should be easy for us to see which is the biggest and which is the smallest. So I can see that this one here is the biggest. So this is number 1 we're going to put down. This is our second biggest, so we're going to put 2. And this is our smallest, so we're going to put 3. Question 6. Express each real number correct to 1 decimal place and graph them on a number line. Because we're doing the last column, we'll look at D and H. D says negative root 12 and H says 187%. So 2 different forms of numbers, and we're going to try and graph them on a number line after we put them into decimal form. So what do we have to worry about in this question? So we can see that real numbers is something that they've mentioned up here. So a real number, we don't need to worry about too much. It's pretty much just the group of numbers that are described. It pretty much means numbers that you can put on a number line. Now you might be thinking, hang on, what number can't you put on a number line? So when you go into harder maths, in uni maths, you'll get numbers like the square root of -1, which is also known as I because it's an imaginary number and you can't actually put it on a number line. But we don't need to worry about them because they haven't actually provided you with any of those fake numbers. So they're all real numbers. We don't have to worry about that. Correct to 1 decimal place. Okay, so that just means 1 number after the decimal point, and then graph them on a number line. Okay, so let's get into D. Negative root 12. Now this negative is the same thing as writing -1 times root 12. Now, that looks a little bit more easier because we know how to do the root 12. We put that into our calculator and we get 3.464101615. Now that's a bit long, so remember to round this to 1 decimal place. We get 3.46, so we're going to change that to 3.5. Now that's so we have 1 decimal place. Okay, let's do this second one here. Now 187%. So what percent means is it's the same thing as saying out of 100. So 187% means out of 100. So remember, you can always replace percent with times 1 on 100 if you want to. Okay, and then putting that into our calculator, we should get 1.87. Remember, you can use your fraction button to change from fractional form to decimal form. Now we should be able to put each of these on a number line. So we've got 3.5 and 1.87. Okay, so they want you to find out for question 7 and 8 what the value of the surds that they've given there, so root 2, root 5, root 10, and root 17, by drawing triangles on a number line. Now, I'm not going to figure these ones out because you will never have to do this ever. It is a very stupid way of doing it, and if I were you, I would get your calculator out to do these, just changing the decimal form, and it'll be infinitely easier. So that's the end of this tutorial, guys. Thank you for watching, and I will see you in the next one.